Alright, trigonometry class, we are going to be looking at section 4.2 in this lesson, and we're going to be, again, graphing sine and cosine functions, but this time our graphs are going to be translated. We're going to have horizontal translations and vertical translations, and then combinations of them both. Okay, so to remind you of what a horizontal translation is, whenever you compare the graphs of, let's say, f of x and f of x minus d, this value that's being added or subtracted right here is the units that it's being translated or shifted over horizontally. So if we add a value to our x, like this is doing right here, our function is moved to the left so many units. Now when our value of x is being subtracted by something, then what happens is it's being shifted to the right so many units. So in this case, it's being shifted right 4 units. Okay, so let's look at something else here. So when we're dealing with circular functions, such as sine and cosine functions, the horizontal translation is actually called a phase shift. So instead of me calling these shifts horizontal shifts or horizontal translations, you'll be hearing me call it the phase shift. What is the phase shift of our functions? All right, so let's go ahead and graph this sine function here that has a phase shift. This right here is our phase shift. Okay, first step I like to do is identify the amplitude. It's going to be 1 in this case. And then identify the period of our function. Okay, so our period of our function is going to be equal to 2 pi over our value of b. And remember, b is what's being multiplied to x, and in this case, it is 1. So our period of our function is 2 pi. Now, the next step after identifying our period, what I like to do is go ahead and split the period into 4 equal parts. So this, since it's 2 pi, you should know what the 4 equal parts are. It's going to be 0, pi over 2, pi, 3 pi over 2, and 2 pi. And now we are going to apply our phase shift. Instead of adding 3 pi over 4 to our each of these angle values here, I'm going to subtract 3 pi over 4. So whatever is here, do the opposite, okay? So for 0 here, let's subtract our phase shift. So negative 3 pi over 4 from 0. Subtract this by 3 pi over 4, and you get negative pi over 4. And then subtract again from pi, you get pi over 4. Subtract this, you get, let's see, 3 pi over 4. Yeah. And then 2 pi, you get 5 pi over 4. Okay, so this right here is our 1 full period applied with our phase shift, which is shifting it over in the negative direction, so to the left, 3 pi over 4 units. So everything that was here has moved over. Let's see, this right here is going to be our negative pi over 4. I'm going to call this our negative 3 pi over 4. Here's pi over 4. And this is 3 pi over 4 and 5 pi over 4. Okay, now that we've got our x values on our x-axis labeled, the next thing is evaluate this function by placing all of these 5 values inside for x. So when we plug in the negative 3 pi over 4 into our sine function, we get the value of 0. So here is where we're going to start. And then negative pi over 4, plug that into x, you're going to get 1. I'm going to call this 1 right here, and this negative 1. So there is that value. Then again, plugging in pi over 4 into x, we get 0, 3 pi over 4, get negative 1, and then 5 pi over 4, we get 0 again. And let's put together that curve. All right, so let's do another example. This time we have a cosine function. And also, remember that this right here means, since it's negative, it's going to be a reflection across the x-axis. Let's go ahead and find our amplitude. The amplitude of our function is going to be absolute value of negative 2, so 2. And then let's find the period of our function, which is going to be 2 pi over the multiple of x, which is 1 this time, so 2 pi. Now, let's split this period from 0 to 2 pi into its 4 equal parts, starting with 0, go to pi over 2, pi, 3 pi over 2, and 2 pi. Now, each of these values right here will be added by this phase shift. So whatever this symbol is, instead of subtraction, we're going to add. Okay, so add pi over 3 to this, and then to this, and then here, here, and here by 3 pi, or pi over 3. Sorry. So what we're going to get first is pi over 3, and then we're going to get 5 pi over 6, and then 4 pi over 3, and then 11 pi over 6, and 7 pi over 3. Now I'm going to label the x-axis with all of these values here. Let's see, I'm going to make that pi over 3. This is going to be 2 pi over 3, 3 pi over 3. This is 4 pi over 3. So halfway in the middle is going to be our 5 pi over 6. And then, let's see, 4 pi over 3, 5 pi, 6, 7 pi. And halfway between that is our 11 pi over 6. Okay. Now the next step on this is to evaluate each of these, plug in each of these as your x values and evaluate your function for y. So plug in pi over 3 in for x, and the value we'll get is negative 2. So let's put negative 2 down here, and positive 2 up here. So here is our first point. And then 5 pi over 6 that was where it's going to cross the x-axis. And then 4 pi over 3 up at 2. Okay, and then at 11 pi over 6, it's going to cross the x-axis again. And then 7 pi over 3 back down at -2. Now let's draw a smooth curve through all of these points. And there you have it, a curve going through all of these 5 points. That is a cosine wave. Will look just like this one right here. All right, let's do another cosine function with the phase shift being subtracted this time. This one's a little bit different than the previous one. Let's go ahead and start with our steps. Find the amplitude, absolute value of 3 over 2, so 3 over 2. And our period of our function, something different this time. It's going to be 2 pi over 2, since our value of b is 2. Okay, now our phase shift. If I ask you what the phase shift is, I did not ask on this question. How you determine the phase shift, it's just going to be what is being added or subtracted from your x value. But in this case right here, it's a little different because we have a different period. How you can go about finding your phase shift is by taking what's inside your sine or cosine function, set it equal to 0, solve for x, and that is your phase shift. So I'm going to call it phase shift is equal to this right here. Well, let's do this. This is how you find your phase shift. Solving that right there. And you get x equals pi over 2. So that means it goes to the right pi over 2 units. Okay, that's how it's the phase shift, how many units it's going over. Okay, you could have done the same thing with the previous exercise. Set what's inside your parentheses here equal to 0 and solving. So our phase shift on this one would be this right here. So whenever it's something other than 1, that's what I suggest, is solving this for x. Okay, if it doesn't have, if your value of b is something other than 1, then do that. If it's not something other than 1, then you can just simply take this value right here as your phase shift. And this is a positive phase shift. It's moving to the right pi over 3 units. This previous exercise went to the left so many units, and calculating your phase shift for these problems, like I just showed you, will help you in determining whether it goes left or right also. So solving for x here, you get -3 pi over 4. So that's telling us it goes to the left 3 pi over 4 units because of the negative sign. Okay, so back over here, here's our phase shift, pi over 2, and that is what we're going to add and subtract from all of our values that we're going to split pi into 4 intervals. So I'm going to start with 0 and go out to pi. So pi over 4, pi over 2, 3 pi over 4, and pi. Now we're going to add pi over 2 to each one of these values to get our x values with the phase shift on it. So add pi over 2 to each one of these. And then once you do that, you will have the x values that we need to plug in and find the y values for. Okay, now let's do that. Let's say our first value is going to be pi over 2. Second one, this is going to be 3 pi over 4, and we're going to get pi. Pi over 2 plus pi over 2 is pi. Then 5 pi over 4 and 3 pi over 2. Now let's, this is telling us we're going to graph this function over 2 periods. Okay, so I'm going to go ahead and label my x-axis by doing this. Okay, I'm going to label it like this. This is going to be my pi over 2, my 3 pi over 4, see 3 pi, yeah. And then my pi, yeah. And then my 5 pi over 4. See how I ran out of room on this graph, but I'm going to go back this direction to get my full 2 periods anyway. So this is going to be negative pi over 2. Okay, so evaluate each of these x values for y by plugging it in to your x value into your function. And then, let's see, if you evaluate y using this x value, pi over 2, let's see, you should get positive 3 over 2. I'm going to say this is my 3 over 2 right here. My negative 3 over 2 is right here. It's right there. And then 3 pi over 4, I'm going to get this value here, it's 0. And then pi gives us negative 3 pi over 2. And then 5 pi over 4 is this value right here. And let's go ahead and evaluate it for 0. So the next one is 0. And then negative pi over 2. It continues with this pattern here. So x-axis, bottom number here, the lowest in your range, and then x-axis, highest in your range, x-axis, lowest in your range. So here. And then keep on going. Let's see, this will be negative 3 pi over 4 right here. Be at the x-axis again. And then let's keep on going. This is going to be negative pi right here. And it's going to be right there. Okay. So draw a smooth curve through all of those values. I'm going to go ahead and plot the last one right here. And that's my negative 5 pi over 4. Now let's see if I can draw a curve through all of those values. Alright, there. I had drawn, while I paused this video, all of the curvatures of this cosine graph right here. Although this is a cosine graph, it looks like it's a sine graph because it goes through the origin here, which, as we discovered, we have a phase shift of pi over 2. And anytime we have a phase shift of 90 degrees or pi over 2 units, we are going to get, instead of a cosine graph, it's going to look like a sine graph. And same goes for if it said cosine of something with a phase shift of pi over 2, it's going to look like a sine graph instead of a cosine graph. All right, let's look at some more examples. Okay, so this is referring to vertical translations, and remember vertical translation, a number is being added to the entire functions, not just the x value inside your function. So whenever you have something being added or subtracted on the outside of your function, like this example right here, we have, we'll shift it up or down. So whenever it's being added, it'll be shifted up so many units, and whenever it's being subtracted, like this right here, it will be shifted down that many units. Okay, we are being asked to graph this function right here, and this one does not have a phase shift, but our next one will, along with a vertical translation. But here, our vertical translation is this right here. So it's going to be shifted down at -2 units. So what I like to do is go ahead and draw in a little dashed line here to represent that's where the x-axis used to be, and that's where all of our, instead of our x-intercepts intercepting the x-axis, it is going to intercept this little invisible line that I just drew here for representing our values being all shifted down 2 units. Okay, so now let's find the amplitude. Amplitude is going to be 3. So our highest value on this is going to be, let's see, 1, 2, it's going to be 1, and then our lowest value is going to be 5, or -5. Yeah. So I'm going to go ahead and write that on here. Range is going to be from 1, -5. Start with the lowest value. -5 to 1. And let's go ahead and find our period of our function. So we can go ahead and split up our x values into its intervals. So period of our function will equal 2 pi over our value b, which is 2 here. So we get pi. All right, so our interval that we are going to be splitting is from 0 to pi. Split that into fourths. We get pi over 4, pi over 2, 3 pi over 4, and pi. So those are the values we are going to plot on our x-axis here. Okay, I'm going to say this is my pi over 2. This is going to be pi over 4, pi over 2, 3 pi over 4, and then this is our pi. Okay, and now let's find all of the y values for each of our x values. So for pi over 4, let's start with 0 actually. When we plug that 0 into our cosine function, what we get is the value, let's see, we get the value 1. Let's go ahead and plot that up here. And then, let's see, for pi over 4, we'll get -2. And then for pi over 2, we will get the value of -5. And then 3 pi over 4, we're back here at -2. And then pi back up at 1. Okay, so let's draw the curve through, or the wave through those 5 points. Okay, so there you go. That is one full period of our cosine function. As you can see, it looks like the cosine function, except it's been stretched because of this amplitude, or this value of 3 right here that we have. And then it was also shrunk down horizontally because of our period being such a small period of just pi instead of 2 pi. Okay, so there's that graph. Now let's look at one final graph that we have left here. It is our function that has both a phase shift and a vertical shift within it. So let's find all of those values before we go and plot them on our graph. So our vertical shift is this right here, is 4. So I'm going to go ahead and just put a dotted invisible line here saying everything is being shifted up here. This is where my x-intercepts are going to lie, just like the last one. Instead of our x-intercepts being on the x-axis, they were here on that little line that I drew. And then we have an amplitude of 2. Okay, this is negative, so our sine function, instead of it going like this, it's actually going to start here and go like that. So it's going to be flipped across the x-axis. And now let's calculate our period of our function and then our phase shift. Or let's calculate our phase shift first. For vertical shift, if we're asked to calculate or find the vertical shift, there you go. Vertical shift is y equals 4. Phase shift is this right here. Solve this for x, and you have your phase shift. So x equals pi over 3. And now our period of our function is equal to 2 pi over b, which is 3. This is our value of b. All right, so now we're going to split the 2 pi over 3 into 4 equal parts, starting with 0 to 2 pi over 3. So remember, multiply 2 pi over 3 by 1/4 to get your first value, 1/2 to get the next one, 3/4 get the next one. There. And then the last one is going to be 1 times that, which is just 2 pi over 3. Okay. So now we get 2 pi over 12, which is pi over 6. And then pi over 3. And then, let's see, 5 pi over 6. And, let's see, 2 pi over 3. So there's 1, 2, 3, 4, 5 parts right there, just like we calculated from above. And now, finally, to these x values, what we're going to do to them now is add the phase shift. In this case, yes, we do add since it's positive. If it was negative, we would be subtracting. So add pi over 3 to each one of these. And let's see, this is what we get. So pi over 3, I'm going to do it right here. So add pi over 3 to 0, get pi over 3. Add pi over 3 to pi over 6. Let's see, you get pi over 2. And then pi over 3 to pi over 3, you get let's see, pi over 2. No, 2 pi over 3. Sorry. And then 5 pi over 6 will be the next one. And then the last one is pi. Now these are the ones that we are going to plot on our x-axis here. So I'm going to say this right here. Oh goodness. This is pi over 3. Okay guys, something that was confusing me before I move on. This value right here, 5 pi over 6, isn't supposed to be 5 pi over 6. It is over here, but I got ahead of myself. And this right here is supposed to be this right here added together, which is, or not multiplied, added, but multiplied. That's going to give us pi over 2. And pi over 2 plus the pi over 3 will give us what we need, which is 5 pi over 6. Okay, now to label our x-axis with the values that we have here that we're going to be plotting. Let's see. We have pi over 3 and let's just label it pi over 2. No. Let's call this pi over 6, and this will be pi over 3, pi over 2, and 5 pi over, no, 2 pi over 3. Just going in order from here to here. 2 pi over 3, and 5 pi over 6, and pi. Okay, now on this graph, do exactly what we've been doing before, which is plug in each of these as your x values into your function and evaluate. So whenever we plug in pi over 3 in for x, we should get 4, which is right on that vertical shift. Right there. And then pi over 2, we go to C 2. And the reason that we go to 2, not only just because whenever we plug in pi over 2 in for x here, we get 2, but our range for our sine function here is going to oscillate between, let's see, because our amplitude is 2 and our vertical shift is 4, it's going to oscillate between 6 and 2, and then go back up to 6, and then go back down to 2. So 2 to 6. Those are our highest and lowest values there. So now, on 2 pi over 3, we get the value of 4 again. I can draw it for you. There we go. And then 5 pi over 6, get 6. and then back down to pi, you get 4. Okay, and then through those 5 points, we need to draw a smooth curve of a sine function. And there you go. There is one full period, but on this thing, we're actually asked to graph 2 periods of our function. So if you continue this direction, go the negative direction, whoops, with our x values, pi over 6, 0, negative pi over 6, pi over 3, pi over 2, and this is what would happen. So since we're here, we're going to be up here, then come back down here, and then go down even further here, and then back up, and then up again, and then back down. And it just repeats that pattern over and over. Okay. Okay, so there you go. There are 2 full periods graphed right here, and you can keep on going. If you're asked to graph 3 periods, then that's why I pause it whenever I'm drawing these curves, because it's actually kind of hard on my tablet. But anyway, you would just keep on going with the pattern, and yeah, I'm not going to try while I'm on camera. But there you go. That's our last example of our function, and that is phase shifts and vertical shifts are all right there for you. So we'll work on all of this in class, and I'll see you when I see you. Until then, bye everybody.